A Fields Medal-winning mathematician recently warned that artificial intelligence has reached a point where it solves open math problems at a PhD thesis level. This is not a future prediction. It is a current reality that signals a profound economic shockwave for entry-level STEM careers. The crisis is not that machines can calculate faster than humans. The crisis is that the entire traditional apprenticeship model for building expert intuition is now obsolete. By the end of this explanation, you will understand exactly why the role of the junior researcher is collapsing and what specific strategic pivot non-engineer professionals must make to remain valuable in an automated future. The data supporting this shift is no longer theoretical. Recent records from the AI contributions to Erdős Problems Wiki indicate that the GPT 5.5 Pro model achieved a full solution for a specific open problem in April 2026. This marks a tangible shift where artificial intelligence can resolve specific mathematical challenges that were previously the exclusive domain of human experts. This capability is not isolated. It is accompanied by the success of the Gauss agent, which formalized Marina Viezoska's Fields Medal-winning sphere, packing proof in a matter of weeks. These events substantiate the argument that entry-level research roles face immediate economic disruption. However, to understand the full scope of this disruption, we must look past the headlines about AI solving math. For years, experts like Kevin Buzzard characterized current large language models as being in an early 80s phase regarding chess computers. He noted they were capable of elementary proofs but were lousy at complex research. The discrepancy between this skepticism from 2023 and the 2026 Wikidata highlights a rapid acceleration that challenges our understanding of the timeline. The speed at which these models have evolved suggests that the window for human-only execution has closed far sooner than anticipated. We are witnessing a transition from heuristic math solving to formal verification, a shift that fundamentally alters where economic value resides in the scientific ecosystem. Quick resource note. I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Consider the traditional career path for a mathematician or data scientist. It relies heavily on the junior researcher role. This is the phase where young professionals spend years performing routine derivations, verifying proofs, and checking calculations. They learn the craft by struggling through intermediate steps, building a deep intuition for why certain approaches work and others fail. This apprenticeship model is the engine that produces the next generation of experts. But when an artificial intelligence can generate and formalize these proofs in weeks, the primary value of entry-level hires evaporates. The work that used to take a junior researcher months to complete is now automated. This creates a new bottleneck in the scientific workflow. The economic value moves from the artificial intelligence that generates the proof to the human who can audit, formalize, and integrate these proofs into safety-critical systems. This is a skill set that is currently rare, especially among non-engineer professionals. The ability to verify a complex formalization, to understand the constraints of the system, and to ensure the output is reliable for real-world application becomes the new differentiator. Organizations no longer need an army of junior staff to do the grinding work. They need a smaller team of senior experts who can oversee these automated workflows and ensure the integrity of the results. The crisis is not a lack of solutions. It is a collapse in the pipeline that creates the people who can judge those solutions. As artificial intelligence handles the Erdős problems and Olympiad-level challenges, the critical career development phase is bypassed. Organizations risk finding themselves without a pipeline of engineers who understand the why behind the how. If the next generation cannot struggle through the intermediate steps, they may lack the intuition required to spot subtle errors in complex AI-generated proofs. This is a systemic risk that goes beyond simple job displacement. It is a threat to the long-term health of the scientific enterprise. So, what is the strategic pivot required for non-engineer professionals? The answer lies in moving from being a solver of defined problems to a synthesizer of cross-domain constraints. The economic leverage now lies in defining the problem space and interpreting AI outputs for business impact rather than executing the mathematical derivation itself. You must stop thinking of yourself as a calculator or a verifier. You must start thinking as an architect of the problem. This requires a shift in mindset where you define the constraints, the objectives, and the boundaries within which the artificial intelligence operates. The emergence of specialized, verified math models indicates a future where the black box of artificial intelligence is replaced by auditable, deterministic pipelines. This means the career risk for entry-level staff is no longer being outperformed by artificial intelligence. It is being replaced by artificial intelligence. Audited workflows that require zero human intervention for standard tasks. The value of human expertise is now concentrated at the top of the stack, where the ability to frame the right questions and interpret the nuanced answers becomes the primary source of competitive advantage. This realization forces a re-evaluation of what constitutes expertise in the modern era. It is no longer about knowing how to perform a specific calculation. It is about understanding the broader context in which that calculation matters. It is about knowing which problems are worth solving and how to translate those mathematical solutions into tangible business outcomes. The professionals who adapt to this new reality will be those who can bridge the gap between raw computational power and strategic human insight. They will be the ones who can navigate the complexity of automated systems and ensure that the solutions generated by machines are aligned with human goals. The path forward requires a deliberate shift in how we approach our careers. We must embrace the automation of routine tasks and focus our energy on the higher-order thinking that machines cannot replicate. This means cultivating skills in problem formulation, constraint definition, and strategic interpretation. It means becoming comfortable with the idea that the work of the past is now done by machines and that our value lies in what comes next. The future of STEM is not about competing with artificial intelligence. It is about collaborating with it, guiding it, and ensuring that its immense power is directed towards solving the most complex and meaningful challenges we face. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.